Welcome back to VMware View 5 Essentials Training. In this lesson, we're going to talk about how to package your applications using ThinApp. We'll start by talking about how ThinApp works and how it virtualizes applications. Then we'll talk about some of the requirements and limitations that ThinApp has. After that, I'll go over the high-level steps on how to virtualize an application using ThinApp. Then we'll talk about some best practices for the machine that you use to package the machine. I'll give you a quick rundown of the pieces that make up a ThinApp project and a ThinApp package. I'll quickly cover some of the advanced ThinApp concepts. We won't go into great depth there, but at least want to introduce you to the concepts. Finally, we'll talk about testing methodologies for the ThinApp packages you create. Then we'll finish up this lesson doing a walkthrough of an actual packaging of an application. Let's start by talking about how ThinApp virtualizes our Windows applications. Just like ESX does for our hardware and operating system, ThinApp provides a layer of virtualization between the OS and the application. This has the advantage of taking the application and partially isolating it from both the OS and other applications that are running. We have the ability to modify how isolated the application actually is, because in some cases we don't want to completely disassociate it from the OS or other applications, while in other situations we may want to completely isolate it. The ThinApp package itself runs in user mode. This has the benefit of not needing to have administrative rights in order to run an application. This does, however, put limitations on some of the applications that can run within the ThinApp bubble, namely anything that would need administrative rights. When an application is launched within ThinApp, it creates a bubbled environment that the application runs within. I like to use the bubble analogy, because a bubble is a semi-permeable membrane that allows some stuff to pass back and forth between it, while holding other things back. Within this bubble, there's a virtual file system and a virtual registry that the application uses to run. The folders, files, and registry keys that exist within this bubble can replace or merge with the OS's file system and registry. We have the ability to determine which ones will replace and which ones will merge. But generally speaking, if it's defined within the virtual file system or virtual registry within the bubble, it's going to mask whatever may exist on the operating system. In some use cases, we actually want to explicitly block access to certain registry keys within the operating system, even though we may not be providing a value within the bubble. As the user uses the application within the bubble, changes will need to be made to the file system and the registry. These changes are kept in a sandbox location that is specific for that user in that application. We can define where the sandbox location is going to be while we're building the package. If we keep the sandbox on a location, that it will always be available to the user, no matter what desktop they're logged into. Whether it's a non-persistent or persistent virtual desktop, or even a physical desktop doesn't matter to ThinApp. Any changes the user makes within the application are stored in the sandbox. So as long as the user can access their sandbox location, they'll maintain those customizations as they roam from desktop to desktop. While we're creating the ThinApp package, we'll define the permeability of the bubble, both at the file system and the registry level. One of the major advantages of ThinApp is the ability to package the application once and then deploy it across multiple different Windows operating systems. The most important thing to keep in mind here is that if we want to deploy it to a certain operating system and above, we need to package it on that lowest level of operating system that we would want to deploy it to. This will come into play when we talk about the best practices for our packaging machine. When packaged, a ThinApp application actually exists as a single executable file, or as a collection of files, depending on how we define the package. This makes it highly portable and simple to access. Each individual executable that makes up the application can become an entry point to the ThinApp package. These entry points will be represented by individual executable files and provide access into the bubble. So let's talk about what you need to have in order to be able to run ThinApp. If your execution platform is a 32-bit, it'll need to be at least Windows NT or greater. For 64-bit Windows platforms, you'll need XP or later. Now you can package 16-bit applications, but they can only be run on 32-bit versions of Windows. They will not work on 64-bit versions. The 32-bit applications can be run on either 32 or 64-bit. And there are some special use cases that work really well for running your ThinApp applications on either terminal server or strict XenApp deployments. There is no deployment mechanism native to ThinApp. This makes a strong case for packaging the application with ThinApp, but deploying it through Citrix XenApp. which has the nice benefit of allowing you to run multiple versions of an application, such as Office, on the same ThinApp server. Now that you know where we can run ThinApp, let's talk about some of the applications that will prevent ThinApp from working. First of all, if an application doesn't work on a certain operating system, it simply isn't going to work, even with ThinApp in the picture. Just like you can't run OpenVMS inside of an ESX VM, you won't be able to run an application that doesn't natively run on Windows. Any applications that require low-level OS interaction or kernel mode drivers simply won't work within ThinApp. These include items such as antivirus and VPN clients and personal firewalls, all of which require some really deep integration with the operating system. ODBC drivers are the one exception to the kernel mode driver rule, because they actually run in user mode, but any other drivers will not work. Any COM Plus or network DCOM packages will not work within ThinApp either, due to the highly integrated nature they have with the network. Now you can package applications that integrate to the Windows shell, but there could be reduced functionality of these applications, because they won't be able to fully integrate in a ThinApp package. You can run COM and DCOM packages within a ThinApp bubble, but they'll be severely limited if they need to talk to other applications or out onto the network. Any 64-bit applications cannot be virtualized, and like we talked about before, ThinApp versions of 16-bit applications won't be able to run on a 64-bit OS. Here are the steps to virtualizing an application with ThinApp. We're going to go very high level here, and we'll get into more detail during the demonstration portion. First of all, you want to start with a clean Windows VM that has ThinApp installed and has a snapshot taken of it. When I say a clean Windows VM, it's a virtual machine with pretty much just a basic install of Windows. The way ThinApp works is a pre-scan post-scan process, so it detects changes made during the installation process. If you have a bunch of stuff already installed inside this Windows VM, and something's already included a DLL this application needs, it won't automatically install it. Therefore, ThinApp won't pick it up, and the application may not work as it's deployed to other desktops. A VM with snapshots on it is preferable so that we can easily revert back to that clean image. This is why when you buy ThinApp licenses, you'll get a workstation license to go with it. The first step in the process is to do a pre-scan before any installation. The pre-scan process will create a catalog of everything in the file system and in the registry. Then you're able to install the application, making sure to do any post-installation configuration and testing of the application. You want to make sure that the application works well at this point, otherwise it may not work in the ThinApp bubble. Otherwise it may not work in a ThinApp package. After all that's done, we can do the post-scan, which again catalogs the entire file system and registry. It will then compare the pre-scan and post-scan catalogs to determine what changed during the installation process. After that, the wizard will take you through a series of configurations for the ThinApp package. This is where we will define what the package will look like. After the wizard's completed, ThinApp will copy all the files that were found to be different between the two catalogs, and actually make a copy of them in a project directory. This gives us the ability to directly manipulate these files and registry settings. We also have the opportunity to modify the package configuration that the wizard helped us to define. Then the final step is to actually build the package, which will create that single executable or series of executables that define the package. We talked a little bit about that clean VM image, but let's take a little bit closer look into some best practices. Of course, you want to use a virtual machine so that you can take advantage of snapshots. This can be either a vSphere VM or a workstation VM. The vSphere VM has the advantage of being available to multiple users without having to copy files. Now, if you don't have vSphere available to you, ThinApp does come with a license for VMware Workstation. You want to take a close look at what operating systems your users will be executing this package on. Usually Windows XP Service Pack 3 is the lowest level operating system that I've seen customers using. This is usually a safe platform to use as our packaging machine. You do, of course, want to use a clean install of the operating system. This means having the minimal amount of software installed. If there's a file that the application needs to run, but it's already there before the installation process, the installer may detect it and not copy that file or registry key onto the operating system during the install process. If that's the case, ThinApp won't see that as a change during the installation process. when it compares the pre-scan and the post-scan catalogs. If it doesn't see that change, it won't copy that file. And any operating system that tries to run it that doesn't already have that particular file or registry key, the ThinApp package will fail. So the goal is to make sure that the installation process will lay down every file it could possibly need. Generally what I do when creating a packaging machine is to just install Windows and any security updates it may have. Try to avoid installing packages like the .NET Framework or newer versions of Internet Explorer. Now this packaging machine can be a domain member. It doesn't necessarily have to be though. Making it a domain member does make it easier to access network shares, where we're likely to store our projects and packages directories. If it is a domain member, you may want to set the computer account within Active Directory to never expire the password, since you will be oftentimes reverting snapshots, which can sometimes cause havoc for the computer account in AD. At the end of the ThinApp, set up Capture Wizard, but before the actual build of the package, ThinApp will create a project directory. In that project directory are several different components. First is going to be a representation of the virtual registry. This is physically accomplished with a series of text files. There's also the virtual file system that it creates, which is a landing point for all of the files that it copies off of the operating system that will be included in the ThinApp package. In almost every directory, there's an attributes.ini file. Within that attributes.ini file, we can define for each directory what level of isolation ThinApp will provide for that particular directory. There's the build.bat file, which we use to actually create the package based on this project. There's a package.ini file that contains all the settings for the ThinApp package. Manipulating this file will change the behavior and structure of the ThinApp package. This is a heavily utilized utility when creating ThinApp packages, but can cause your ThinApp packages to not work as well. So you'll want to make sure that you test thoroughly any changes you make. Finally, the project will also have a capture machine overview.txt file. This file will contain information about the Windows system that this application was captured on. After running the build.bat, we'll actually have a ThinApp package that we can execute. This package consists of several different components, including the virtual registry and virtual file systems that exist within the bubble. There's the primary data container, which contains all the files that make up the virtual file system, and will be the center point for any ThinApp package. You may potentially have separate entry points from the data container as well. Each of these will be very small executables that link directly back to the primary data container and represent the different application executables. Think of an application like Office that has multiple different products that make it up. Your primary data container will be a standalone file by itself, whereas Word.exe, Excel.exe, and Access.exe will all be represented by small executables that are dependent on that primary data container. For each user that executes the package, they'll have their own individual sandbox that will contain all the changes the user makes while inside that ThinApp bubble. You also have the option to create an MSI package. This can be used to deploy the ThinApp packages out to the end user's desktops. It's also useful for some ThinApp deployment technologies, like VMware View, that are based on the MSI package rather than the package itself. Now there are some advanced ThinApp concepts that we simply don't have the capability to cover in this lesson, but I do want to make you aware of the functionality here. Within the package.ini, there are several settings that could come into play in many different applications. First of all is the concept of app links. App links are the ability to take two ThinApp packages and execute them together in a single bubble. One useful example of this is the vSphere client, which we can package separate from the .NET Framework. The vSphere client will fail if the .NET Framework doesn't exist. So if we want to package them separately, we can simply define an app link within the vSphere ThinApp package to automatically load the .NET package into the same bubble, thereby granting the vSphere client access to the .NET Framework. You can define these as either optional or required, the difference being that any required app links that are not found will prevent the entire package from launching. You can also define properties of the sandbox, the main one being the location of the sandbox for each user. We can also define whether or not the sandbox is deleted when the user exits the application, and several other settings that can be used to manage the sandbox. The AppSync parameter can be useful when distributing your ThinApp packages outside of your corporate infrastructure. AppSync works through an HTTP URL, which provides access to updated ThinApp packages that are distributed outside the corporate network. When launching a ThinApp package that has AppSync defined, One of the tasks ThinApp is going to complete is to check to see if there's a newer version available at the AppSync URL. If there is, ThinApp will stream down that new update in the background while launching the current version of the package. When the user closes the ThinApp package, it'll replace itself with a newer version, thereby giving the user the latest version on the next launch. You can also define configuration information about the MSI package, and any other settings that are defined during the Setup Capture Wizard can also be modified in the package.ini. This is particularly useful when testing a ThinApp package, because you may make assumptions during the Setup Capture Wizard that you'll find out is incorrect during testing. Being able to modify these settings within the package.ini allows us to update the package without having to completely recapture it. The isolation settings within the registry and file system can be modified and tweaked down to the directory level or the key level within the registry. This is defined in the registry files and the attributes.ini files. The defaults can be defined in the package.ini. Some applications will require specific isolation settings in specific directories and registry keys, and this can be a primary point of troubleshooting a package that isn't working quite the way you want it to. ThinApp provides an SB merge utility, which you can use to update a package based on the updates that are contained inside of a sandbox. ThinApp gives you the ability to embed scripts into the packages that can modify the behavior of a package at runtime. One good example of this is creating a script that will define whether an application can be run based on the current runtime parameters, which can provide extra security for your ThinApp packages to make sure they're not launched by someone who's not authorized. Finally, let's talk about testing our packages. The quickest test that we can execute is the dirty test, which is testing the package on the same machine that we captured it on. We call this the dirty test because we're not running it on a clean machine. By having the natively installed application available underneath the ThinApp package, we could potentially mask issues that we would have on a clean machine that didn't have the native installed application underneath of it. The wash test is testing the application on the same packaging machine, but after having uninstalled the application. This makes it more likely that we'll find issues, but an uninstall doesn't always remove all files. So there could still be some files that could be accessed by the ThinApp package on the native OS that could mask potential problems. The best case is to do a clean test, which I usually do simply by reverting the packaging VM, powering it back on, and running the ThinApp package there. Our final test is to use an actual production desktop, which will have all the proper group policies applied and all the software packages that an end user will already have installed on their desktop. So now let me show you an actual ThinApp package process, and we'll talk in more detail about all of the configurations that are available while we walk through it. Really, the best way to understand how to package an application using ThinApp is to watch somebody do it. So let's go ahead and jump in and do that right now. Before showing you the actual process of ThinApping an application, I'd like to make a quick stop here in the vCenter client, where I want to show you the ThinApp virtual machine that we'll be using and the snapshots that I've created on it. First off, notice that there's nothing special about the hardware configuration, other than it is VM version 8, and it has a single CPU with 512 MB of RAM. It is a Windows XP professional machine. The snapshots I've created include ThinApp Packager Base, which is a basic installation of Windows XP, and a ThinApp 4.7 snapshot, which indicates the installation of ThinApp 4.7. These were both taken while the VM was powered off. Now let's jump into our ThinApp packaging process. We're going to package the Opera web browser in this case. It's a small install that can be done quickly and shows how to package the application. Obviously, there are much more complicated applications out there, but this is a simple one that we can quickly install and test. So the first step of the process is to run the ThinApp Setup Capture. For those users that are going to regularly be using the packager, I like to put the shortcut right on the desktop to make accessing it easier, rather than having to go through the Start menu. You'll notice I also have shortcuts to the Projects directory and the Packages directory, both of which exist out on the network. This allows quick access to those two directories, so I can easily copy out my packages and projects when I'm completed. Let's start by opening up the Setup Capture Wizard. This first screen gives us an overview of the entire process, including a quick start video that we can play, and a link to the ThinApp community. will also tell us the version of ThinApp that we're running. Clicking Next takes us to the pre-scan screen, which explains what a pre-scan is, a quick description of what a clean Windows system is, and why we would want to use it. We can also click the Advanced Scan Locations button, which gives us the ability to define what ThinApp should and shouldn't scan for both file directories and registry hives. Generally, we won't make any changes here, so we'll just click OK. Now we can start the pre-scan process, which will create a catalog of all the files, folders, and registry keys that exist on the system before we do our installation. As you watch the scanning location, notice the directories that it is scanning, and now we see its scanning locations within the registry. Now that the pre-scan is complete, we can install our application. If you do happen to close this wizard or need a reboot as part of the installation, simply run the ThinApp Setup Capture wizard again after the application is installed. The first thing the wizard is going to do is check to see if there is a pre-scan already completed on this machine. If there was, it'll bring it up and ask if you want to continue with that pre-scan or start a new one. If you choose to use that pre-scan, it'll take you directly back to this screen. So let's go ahead and close this window, and we can run the Opera install. We'll go ahead and accept the terms of service and install the application. Now that the installation is completed and the application is automatically launched, we'll go ahead and just close the application. Notice we have an Opera shortcut on our desktop and an Opera shortcut within our Start menu. No reboot is necessary, so we'll go ahead and just run the ThinApp Setup Capture wizard again. The wizard here has recognized the fact that we've already done a pre-scan, so we can choose to continue with it or start a new one and delete the previous. We want to continue, so we'll click Next, which takes us back to the Install Application Now screen. At this point, we have one other option. We could choose to change the Internet Explorer entry points. The default is to not include an Internet Explorer entry point, which is what most packages need. You can also choose to include an entry point for the system-installed IE. This will include an entry point that is based on the Internet Explorer that is currently installed in the Windows image that this package is currently running on. So if I'm running Windows 7, and it has Internet Explorer 9 installed, that's the version of Internet Explorer that will be opened inside the bubble. I can also include an entry point for a fully virtualized version of Internet Explorer. When running the Setup Capture wizard on a Windows XP machine that has IE6 installed on it, ThinApp can actually harvest out Internet Explorer 6 and completely contain it within this ThinApp package. So in executing this package on a Windows 7 machine that's either going to have IE8 or IE9 installed, launching Internet Explorer within this package will actually launch IE6. This can be really useful for some older web-based applications that don't support the newer versions of IE. These are pretty rare, but this can be a huge benefit for those particular packages, especially if your organization wants to move on to Windows 7. In this case, we don't need an entry point for IE, so we'll go ahead and cancel out of this and leave the default, which is to not include an Internet Explorer entry point. Now we can go ahead and run the post scan, which will do essentially the exact same scan we did during the pre-scan and create a whole new catalog. It'll then compare the two catalogs to determine what's changed between the pre-scan and the post-scan, which will result in capturing all of the files and registry entries that the application created. We get one last chance to determine whether or not we're done with the application. We know we have, so we'll click OK. As part of the comparison between the pre-scan and post-scan catalogs, ThinApp has determined what executables exist on the system, and gives us the ability to define which ones are going to be entry points. In this case, it's determined that opera.exe in the program files directory, under the opera directory, is the main entry point for the application. It does this based on the shortcuts it finds on the desktop in the Start menu Programs directory. It also found a Netscape executable within the Opera directory. ThinApp didn't find any shortcuts to this particular executable, so it didn't automatically check this. And we have no reason to include an entry point for this particular executable, so we won't check it either. The Show Entry Points used for debugging checkbox allows us to choose additional entry points. The cmd.exe and regedit.exe are two executables that can be useful when troubleshooting inside the ThinApp bubble. Using command.exe as an entry point, we'll be able to easily root around inside the virtual file system within this ThinApp package. Using the regedit.exe as an entry point, we'll be able to go into the virtual registry of this ThinApp package, which can provide good clues, which can provide a great amount of information when having to troubleshoot why a ThinApp package isn't working. In our case, we'll choose command.exe to give a good example of how this works. But otherwise, we probably wouldn't need this in most cases. The next screen is a new feature with ThinApp 4.7, which provides compatibility with VMware's new Horizon Application Manager. Horizon is a software-as-a-service, cloud-based application that allows single sign-on and self-service delivery of applications for corporate infrastructure. This piece of functionality within ThinApp allows deployment of ThinApp applications via VMware's Horizon application. There's a lot of great things that you can do with Horizon, which we can't get into here. But by simply checking this checkbox, it will provide the ThinApp package the additional functionality it needs to be compatible with Horizon. We're not going to configure that here, so we'll leave this unchecked and click Next. Now we can choose which groups are going to be authorized to run this package. This utilizes Active Directory groups that are defined directly within the ThinApp package itself. The groups that we choose here will actually be encoded by GUID rather than by name. In order for a user to be able to execute this ThinApp package, the user must first be a member of the group within the domain that this package was created in our case, the home.int domain, and the machine that it's run on must be a member of that domain as well. So it can properly check for that GUID to ensure that the user is a member of it, and if all checks out properly, the application will launch. If not, the application will display this access denied message in this box down here. We're going to keep this package simple and allow everyone to execute this package. And then we can click Next. Now we get to choose the file system isolation mode. We have two default choices that we can choose here. And this is just the default mode. We can go in and change specific directories later on. Our two choices are the full write access or merged isolation mode, which provides the ThinApp application greater access to the underlying operating system and isolates only the application data, system, and program files directories into the sandbox. Any other writes that the application makes will go directly to the underlying operating system, rather than being captured in the sandbox. Applications like Microsoft Office that carry the Windows logo certification are generally written properly, so they don't write to the incorrect directories, and will generally either store data in one of these three directories, or in the My Documents area, which with best practices will redirect out onto the network anyway. For applications that we don't trust, we generally want to choose the restricted write access, or write copy isolation mode. This redirects almost all directories to the sandbox, with the exceptions being the desktop and the My Documents directories. In our case, Opera is a pretty well-known application, and one that we trust will write in the proper directories. So we'll go with the full write access, and click Next. Now we can choose where the sandbox is going to be located at. The default is to store it in the user profile, which is contained in the app data directory in a thinstall subdirectory. We can also choose to save it in the same directory as the ThinApp package. This works best for USB deployed packages, which we'll talk about in the next lesson. But this way the user can contain both the package and their customizations that are stored in the sandbox on one USB stick and carry it from machine to machine. Our final choice is to use a custom location or network drive, where we can store those packages at. This can be useful if we want to redirect the sandbox out onto the network and be able to save application states of our ThinApp packages for the user to be used from one session to the next. This can also be accomplished by redirecting the app data out onto the network. In our case, let's go ahead and set a custom location so we can see the sandbox very easily. We'll save these out on our NAS01 device, in the share called ThinApp, in a directory called Sandboxes. We'll add in the %username% variable to ensure that each user gets their own subdirectory. Now we can click Next. VMware uses quality assurance statistics to help improve the ThinApp product and to gather information about applications that users are successfully packaging with this product. So we'll go ahead and help them out by using the default Yes, I wish to help. When packaging applications, ThinApp will check to see if it's a browser that we're packaging. If it is, ThinApp gives us the ability to utilize the ThinDirect feature of ThinApp. ThinDirect works by installing a plugin into the native Internet Explorer when registering the ThinApp package with Windows. This plugin will then redirect any websites that we identify in this box to open up with the Opera ThinApp package. So for example, if we enter trainsignal.com here, anytime we go to TrainSignal in Internet Explorer, it will automatically redirect to use the Opera application. This can be very useful when you need to direct certain websites to certain web browsers due to compatibility issues. Next, we get to choose the inventory name. This inventory name will show up in the add remove programs, which inventory tracking utilities will use. It'll also be the name that is used for the sandbox location. In our case, we want to drop off the build number and just use Opera 11 as the inventory name. You can also identify the project location, which is the directory where all the files that make up this ThinApp package will be put into at the end of this wizard. We're good with this default for now, so we'll click Next. Now we get to define what our package is going to look like. First, we get to choose what our primary data container will be. We have the choice of either using one of the entry points that we selected, or using a separate DAT file that the packager will create. Generally speaking, ThinApp's going to make the proper decision for you here, but the main reason for choosing a separate DAT file is if you have a lot of different entry points and you don't know which ones in particular you're going to want to deploy. Generally speaking, ThinApp is going to make the proper decision for you between these two choices. This is based on the size of the primary container. The primary data container contains all the files and registry information needed to run this ThinApp package. It's the main storage location for the entire package. It's the main storage location for the entire application. If the size of that application ends up being larger than 200 meg, it'll automatically choose the DAT file. Because Windows XP and Windows 2000 both have issues with executable files that are larger than 200 meg. By making all the entry points the EXEs, and having them all linked back to a central DAT file, you get around this issue. One good business reason to change it from this default to using a separate DAT file is if you have a lot of entry points, and you're not sure which ones are actually going to be deployed to the end users. If you put it in a separate DAT file, then you have the ability to delete entry points that you no longer need, after the application's already been packaged. The MSI package generation allows you to define whether or not an MSI package is going to be generated. MSI packages are useful in several different instances. If you want to deploy the ThinApp package directly to your Windows stations, using traditional software distribution methods, your deployment tool can use the MSI package, which is really just a wrapper around the ThinApp package itself, and the ThinReg utility that is used to register the application, and the ThinReg utility, which is used to register the ThinApp package onto Windows. You'll also need an MSI package for other ThinApp-specific deployment utilities, like VMware View and Horizon, and VMware Horizon. We'll go ahead and generate the MSI package so you can see what that looks like. We'll also use this MSI package in the next lesson, where we talk about deploying ThinApp packages. Finally, we can choose whether or not we want to compress the virtual package. By checking this box, ThinApp will compress the package while it's building it. This has the benefit of having a smaller package in the end, but increases the amount of time it takes to package the application. So it's generally recommended to not compress it until after you've tested the package and ensure that it's completely working. This is one setting that's easy to change in the package.ini file afterwards, so I almost always leave this unchecked the first time around. Notice now that our button is Save instead of Next, because at this point we've completed all the settings that it takes to build our ThinApp package. Now what's happening is ThinApp is copying all the files and registry settings it found that differenced between the pre-scan and the post-scan catalog. All these files were saved out in the project directory that we defined as part of this wizard. On the Ready to Build screen, it shows us what items are going to be created as part of the build process. It also gives us the ability to edit the package.ini file and open the project folder. You can also choose to skip the build process altogether. Let's go ahead and open up the project folder so we can see what that looks like. In this project folder, we have a whole series of variable name directories, which represent specific directories within a Windows operating system, including the app data, the desktop, the common desktop, and the program files dir. So for example, the program files dir represents the C program files directory, where we can see there's an Opera directory and all the files that were installed as part of the Opera installation. In most of these directories, you'll also find an attributes.ini file. Inside this ini file, there's usually only a single setting, which is the directory isolation mode. This is where we can change each directory to have its own isolation mode, different from the default. For example, in the program files directory, which is obviously specific only to this one application, it's automatically changed to use a write copy instead of the merged isolation mode that we selected as the default. This ensures that any changes that are made to this directory within the ThinApp bubble are written to the sandbox, rather than to the underlying operating system. In this package, we'll also find a build.bat file that will be used to build our package. So we'll come back to that one. You'll see 3 different HKey text files, which represent the 3 main hives of the virtual registry. It'll be added as part of this package. Opening any one of these, we'll see that each registry key has an isolation setting, most of which will either be full or write copy. It then lists the actual key name, its value, and the setting that value is given. You can directly manipulate at this point any of the directories or registry keys to make tweaks without having to redo the entire packaging process. We have our package.ini file, which contains many settings. Let's take a quick tour through the highlights of some of the settings that are in here by default, which will cover about 90% of all the settings you'll ever need. First of all, you've got the compression type. Once we know this package is functioning, we can come in here and change this from a none to a fast compression and simply run the build.bat again. We have our default isolation mode. We have our build options for the MSI package, which you can see we can manipulate directly here. The product code and upgrade code are 2 pieces that come into play when you're deploying your ThinApp applications using the MSI installer, especially when you want to do upgrades from one version of the application to the next. We have our app sync parameters, which provides us the ability to update our distributed ThinApp packages by supplying updates at a URL that's predefined inside the package. AppSync is pretty unusual to use in a VDI situation, since most of our users are accessing their ThinApp applications directly off the network. They're therefore very easy to update. We have several parameters that are used during the setup capture, including our sandbox location that we've already defined, the access denied message, what version was used to capture this application, and where our output directory is for the package that will be created here, which by default goes into a bin subdirectory of our project location. Next, we have a series of general purpose parameters, including our sandbox name, our inventory name, what icon will be used for the package, the permitted groups if we define any in the wizard, whether or not the sandbox will be deleted when we exit the application. This can be useful for some applications where we don't want to capture customizations the user has made, whether or not we want to sandbox network drives and removable drives, and whether or not we want to virtualize the external out-of-process COM. These last three are pretty uncommon settings, but are available here for specific use cases. After that, we can define our optional and required app links, and we can define any virtual drives that we want to appear within the ThinApp bubble, as well as defining a computer name that the application will always see that it's on, masking whatever the actual Windows name is that is executing this package. Now we'll skip some very specific use case settings and jump down to here, which starts our area where we have all of our entry points. For each entry point, we can define a source, which should always point to the executable inside the package that we want it to execute. By defining the read-only data parameter, we indicate that this particular entry point is going to be our primary data container. The working directory identifies inside the package where this application resides. The file types and protocols parameters define the file types and parameters that we want associated with this ThinApp package when registering it within Windows, so that when users double-click on an HTML file, it'll automatically open up Opera within the ThinApp package. Finally, we can identify the shortcuts that we want the registration process to add into the Windows directories. For any non-primary data container entry points, we define a shortcut parameter that defines which file is the primary data container for that entry point. And most packages will contain entry points that have a disabled parameter defined for it. This is simply flagged to let ThinApp know which ones we want to actually create and which ones we don't. So that's a quick run through the package.ini. Since this course is designed specifically for VMware View and not for ThinApp, we'll leave it at that for now. At the end of this lesson, I'll point out a couple of resources that you can use to dig deeper into the package.ini and some of the settings that are available in here. Finally, we have our ThinDirect, which identifies which URLs will be associated with this particular package. One important step at this stage is to go through this virtual file system and do any cleanup operations that may be needed. This could include cache and uninstall directories that aren't needed in the final package and will only cause the package to be larger in size. For example, since this is a web browser, we'll have a cache location. If we did any browsing at all, files will be added to this cache location, and we'll want to clean those out since we won't need those on every execution. So in our local app data, we'll open up the Opera directory and go into the cache directory. There's obviously stuff that's been created in here already that we probably won't need. So we'll go ahead and select them all, but deselect this attributes.ini file, because we do want to define the isolation mode of this directory. Now that we've done some of our cleanup, we're ready to build our application. We can either choose to execute this build.bat file, or we can click the Build button in our Setup Capture wizard. Either one is perfectly valid and results in the exact same process. We'll go ahead and run the build right here in the wizard. Both methods will show us the same build output, which is sometimes easier to see in the batch file since it opens up in a command window. Now our build is complete. As soon as we click the Finish button, we'll open the folder containing the project executables. We'll choose not to do this, since I want to show you the exact location of these files. Clicking Finish closes the Setup Capture wizard. In our project folder, you'll see now that there's a bin directory. Opening up this bin directory, we'll see three files: our command and opera.exe entry points, and the Opera 11 MSI file that we told it to create. At this stage, we can go ahead and perform our dirty test by running the application directly here. And now clearly our package is working, at least in the dirty test. The reason we call it a dirty test is because both the native installed application and the ThinApp package are running on the same system, so it's easy to mask any issues we may have with the package itself, due to the fact that those files still exist on the native operating system. Our best test is to revert the snapshot on this machine and test in a completely clean pre-Opera environment. But before we can do that, we need to copy all these files out onto the network. So let's go ahead and copy this Opera 11 directory. And open up our shortcut to projects, where you can see we already have a Google Chrome and a Mozilla Firefox directories created. We'll simply paste the Opera 11 project directory out here. Now let's also go into the bin directory and copy our package files, which we want to copy out to this package's network location. Out here we want to create a new directory called Opera 11. And paste our files here. Now we've copied all the relevant files out onto the network, so we can go and revert the snapshot for this VM. Back in our vSphere client, we'll simply use the Revert Snapshot button. Which takes our VM to a shutdown state, so we'll want to power it back on. After waiting for the VM to power back on, we've logged in and can now access the packages directory, where we can open up Opera 11 and execute our ThinApp package. And here we can clearly see that Opera is working during a clean test of the ThinApp package, because there's no indication that Opera has ever been on this machine. So that's the quick rundown on how you can create a ThinApp package. That's by far the most simplest demonstration of packaging. But that should be enough to get you started on creating your own ThinApp packages. There's no doubt that there's more depth to that, so I'll point you to some great resources out there that I've used many times. First of all is the ThinApp User's Guide, which is updated for every version of ThinApp and has a ton of great information in it, including most of the package.ini settings. Then there's the ThinApp Reviewer's Guide, which kind of walks you through the whole process of evaluating ThinApp, including the installation and walking you through the packaging process. There is a ThinApp community out there where people can submit their own recipes for how to package applications within ThinApp to achieve the greatest efficiency of the application. The ThinApp team blog is a great resource that I use a lot. One of the best things they post out there are step-by-step guides on how to package certain popular applications, like all the Microsoft Office versions, going all the way back to Office XP. They've also produced, as of 4.7, a package.ini parameters reference guide, which does a deeper dive and a greater listing of the different settings you have available to you in the package.ini file. I recommend checking this out if you have problems with the ThinApp package or want to know more about what you can do with the package.ini file. So let's wrap up with a quick summary of what we covered in this lesson. We first talked about how ThinApp works and how it works to separate the application from the operating system. We talked about the different requirements and some of the limitations on applications that it simply can't package. I walked you through the high-level steps of how to virtualize an application with ThinApp and some of the best practices for the machine that you use to do the packaging. I gave you a short inventory of what makes up a ThinApp project and a ThinApp package, and then went through a few advanced concepts like app sync and app link. Then we finished up the lecture portion by talking about some of the testing methodologies that you have with ThinApp, including dirty tests and clean tests, which are the two main tests you're going to provide to any ThinApp package. And as usual, I wrapped up with a walkthrough, where we went through the process of virtualizing an application, in this case the Opera web browser. and that's creating a ThinApp package. Now I highly recommend you watch the next lesson in this series, which covers deploying these ThinApp packages. Thanks for watching.